Hello and welcome back. Today I'm gonna play a little bit with this device. It is the ADF4351, and I already had a review about it, and it gave me a lot of questions. So that is nice, the viewer interaction. And one of the questions was, where can I find the software? I have put a download in that video. I will also do in this one. And I will show you how to install, because I noticed that you can run into some problems if you already have a lot of other USB devices. So I will show you how to do that. And the install file I put was a zip file. Within that zip file were two other zip files. And the installer that said setup, but the setup only installed the serial driver, and you maybe don't even have to do that. So I will show in my screen how I did it, and then probably that's helpful for you too. And other questions were, there is one exit, of course, where the signal goes out of the signal generator, but there is also the MCOK, and it is now an output, and it just outputs the local clock it's running on, and this one runs on 25 megahertz. But if you go to the setting menu, you can also set it to 10. So some people ask, what if we use it if we sort of try to switch off the internal clock and we use the M clock signal as a reference, because then you connect it to your GPSDO, and then the signal is spot on. So first of all, will that work? Well, I have the schematic diagram I will show you, and it is possible, but it's all very, very small, so I will get my microscope, but I show you. And then the second question is, okay, if we can do that with 25 megahertz, let's try to do it with 10 megahertz, because my GPS DO doesn't run on 25, it outputs 10. Okay, so we're gonna try that both. And even there was another question, would the signal be more precise if instead of putting a square wave, you put a sine wave in as a clock signal? Well, I doubt a little bit, because I think clock is clock. So it's just TTL to sync the PLL, but maybe it's true. Let's see. So if we can do 10 megahertz, I can also do a nice sine wave as a clock signal. So let's see. I will start with the software, because maybe yeah, maybe the patient dies during the experiment, and then we cannot do the test with the software again. So I do that first. Well, let's see about the clock. We get the schematic diagram. I will put again the camera on the screen. I still not that familiar with the screen capture program. Maybe I have somewhere an old version of Camtasia, but I never played with that for real. So we just need to do it like this. So let's go to the schematic diagram. Okay, here is a part of the schematic. What is the most interesting? I also put it in the download link of the other video, but I will also do that here. You see here, it is not exactly this one, but it is a similar one. And this clock even runs on, let me get it back, sorry. Yeah, this clock even runs on 54 megahertz, but our clock runs on 25. And as you can see, here is the MCOK well, input slash output, and there are two resistors here. So by leaving this resistor in the R8 or R5, and the signal here comes out of the, I don't think you see my mouse. Let me get that back. My pointer. Let's see. Here is the output. Here is a 0 ohm resistor. So, and here is, so it's just a connection. Here is also 0 ohm. So the output of the oscillator that we want to switch off or make switchable, output goes here into the PLL ref input, and there's some DC blocking here. Here is to make your 50 ohms, just to get the right impedance. So that goes straight in. and it can also go out. So if you want to inject a ref signal, you can just remove this R5, this 0 ohm that is on the output of your oscillator, and then you can just feed in here the 25 or the 10, whatever you want to use. But first I like to try with 25 megahertz and later with 10 megahertz, of course, because then that is what comes usually from the GPSDO. What you maybe can also do, instead of removing this resistor, is just switch off the power of the oscillator. So this L1, this maybe we can also remove. It depends on the circuit board because it's all very, very small, and I will get my microscope. Depends which is more easy to remove, because this would be the most obvious choice. But if this is hard to reach, maybe I will choose to remove this one. And if this is not powered, then it's also not a problem. I think it's still in parallel. We're just gonna try that. And then you can also feed in the signal. So I think we have two options. So let's see how it looks in the board. Okay, first let's test the theory before we're gonna open anything. Is there indeed an output? Because what we've seen in the schematic diagram, that it was just in parallel of the line to the PLL that this oscillator would run. So I'm just gonna connect it to the oscilloscope. I think you have a good look at it. I will just power up the signal generator, and I don't think I need the terminator because we already saw in the schematic diagram that it already was terminated, and we are just in parallel. And so this is super high impedance, so that's okay. So I'm just connecting the clock output to the oscilloscope. And here we see it is sort of a square wave. Yeah, I think it's clear enough. So it is, there is a square. It is indeed almost 25 megahertz, and I noticed in the review it was a little bit off indeed, and it's 24.9998. So according to my oscilloscope, and my oscilloscope doesn't have external reference. So when the warranty expires, I'm gonna do that, of course. But now it is still good. So let's see on the if we feed it into the frequency counter. It is indeed almost 25. So that theory is correct. Now let's have a look at the components. Well, we cannot really reach the components right now, so I'm just going to take out a button. That is just protection plate. The screws were not very tight, so I can just unscrew that. Okay. Well, here we have it. I will put it on the microscope, but having a quick look. Yeah. Here is the output for the MCLK, and here clearly you can see the little generator, the little oscillator, I mean. So somewhere there we should see those resistors that we saw in the schematic diagram. And let's have a look in the microscope. Switch it on. I don't want to damage the screen, to be honest. Oh, let me have it. Just put some paper in between. It's already focused. Yes. Well, ooh, a lot of reflections. But if you see, I will zoom in a bit more. Okay, here we have it. This is the MCLK output. You can see here is that resistor. It seems that there is a track, but it is not. It is, I don't know what it is. Maybe it's just the grounding that I just put a little pin here, because the signal clearly goes here, here, and then to here. So this is that, it says here R3, but in our schematic that is R8. So this one we need. We are not going to break this one. So I'm trying to move a little bit. And here on this pin, here we have a little capacitor, and here is a zero resistor. And this is the L2. It goes here. So I would think this is the power. So if we remove this one, then the power to the oscillator stops. So that can also help. Here we have the other resistor here, the R7, which in our schematic is R5. The signal goes out through this R5 in our schematic, and then it goes in parallel to the output, and then here it goes to a capacitor, and then here we probably, in this line, we should have somewhere the 50 ohms. Not 50 ohms is not even there. It goes directly into the PLL. So yeah, in the end, I don't think the impedance is really a problem if you just use it as a clock and it goes directly from the oscillator. But it could be an issue if you gonna use it here with your clock. So then we just need to put here 50 ohms over this one, because you can try to do it here, but yeah, the distance is nothing. So I would just terminate it here then with 50 ohms. We can experiment with it. So two options: remove this one or remove this one. Just see what is easier to do. And here it looks both very easy, but let me tell you, if you look at it in real size, it is very, very, very small. And then maybe, let's see, where's my pen? Maybe it's even easier to remove that one. And that was our, yep, where are we? Yeah, that's probably the R7. And in that schematic, it's R5. So perfect, because that is just removing the output from the oscillator. Let's find some courage to do this. Okay, I thought I used my little rework station, but it's all the way there, so it's too far away. I need to think of something that, so I'm gonna use my Weller. But I have now a very big point, so I think if I even get close, you can see it on the screen. I also need to clean it, I see. That would probably be too much, although maybe this needs to go. Maybe I can just heat it in one go and just push it. Maybe it's not even too bad. I was thinking of using this point. That's also a magnet stud. And then it's maybe better. But I think if I clean it, I think it will work. But it's super, super small. And I just need to be super careful not to, but I think it's possible just heating it like this. I think in the end, this might be better. Yeah, I'm gonna use this. So while the iron is heating, so what we're gonna do, we're gonna remove this one. And then if you feed in the signal, it just goes here, here, into this, into the PLL. So this will keep running, but the signal just doesn't pass. Now it's going to be tricky because it's really, really small and I really need my screen to see what I'm doing. And here you see, it's easy, but really if I use this and I clean it a little bit, but it still looks dirty, but it is not. But it's so small. Let's see if I can just push against it and it will melt a little bit. So small, I'm so scared I'm going to damage something. Yeah, there it went. Go, you. Go, move. I can see it's melting, but it just doesn't wanna. I hope it would keep some heat and then it would just go. But yeah, we got it. Good. And now it can just go. Yeah. Okay. That is done. And now you can see that the signal from the clock here goes through here, 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 and then here through the C's into the. Let's see if I can clean it a little bit more. Yes. I think that's good. Well, and if you think, why was it so difficult? Well, here you see the resistor, and if I move, I will show you the pen. Well, let's see if indeed the clock signal is not there anymore. We need to fill this. The RF out, the clock. I hope it starts, or I'm not sure if the PLL or the whole computer system, the processor system, if it has its own clock or not, because otherwise it would probably not even start. But then it just doesn't start. So we should not have any output. Just connecting it here. I have some USB cable, power only, just here. And it does start it. That is good. And is no signal. Yeah, there is, but we are looking here at millivolts, so that is just what it receives somehow, so we can just screen past that. Okay, now I need to input the signal, and it was 25. So first I'm gonna put in 25. That means I need my other PLL system, and I need to see what output I have on 25. I'm not sure if I'm on my GPS or on my PLL. I think this is it. COM1, yes, English first. Open COM, error, okay, and then I need the other. Open COM, doesn't want to do it. Why not? No, it's the second. I'm sure it's COM1. Okay, I reboot the computer. Okay, so this is the, then if we input that, I need to know which input, but I need to have SMA. I have here a small one. Okay. I'll wait for the computer. Okay, that is better. And I have an output of 25 megahertz on output 5 and 6. So close COM. So 5 and 6 is one of these. Well, I can check quickly on the scope if that is indeed the case. A lot of signal there. Yes, but it even looks more or less the same. Probably if I do a termination, it looks exactly the same. Yes, it does. Okay, and it's 25.00000 because this one is also linked to my GPSDO. So okay, but yeah, let's try to connect it on this side. So we are now feeding in 25 megahertz into the clock. I'll power it on. It does start. Do I have something on the output? It should not. Let's just put 100 megahertz and 50. I put 50 megahertz and then it should be exact if it works. Frequency, back, 50, and point, and I need to have the correct input, of course. Hey, that works. Look at this. I can do a little bit more precise, and the least significant. Well, I think this was a success. Look at this. I think this works. Okay, but then another interesting question: will it also work on 10 megahertz, and then that you set the system to 10 megahertz? Because one of the viewers said, yeah, of course, 25 megahertz is nice, but my GPSDO has an output of 10 megahertz, and I will stop the signal. You go to settings, and here you can set a reference clock. So what will happen if we put this to 10? And yeah, then it should still be okay. Because if I put it now to 10 and we feed in 25, then the frequency it will output is probably too high. So I'm not gonna do that, but I'm gonna set it. I switch it off first. I will go back. I switch it off. I will feed in 10 and put the reference also to 10. So again, check, double check. I'm gonna see if indeed the export here is 10. Oops, this is always a little bit tricky. Well, that is 10. 10.0000000. So this we can use. I only need to change the output. So I'm going to change that to this one here. Let's switch it on. No, I'm not seeing it. Let's switch this on. We go to the setting menu. Okay, we go to settings. How do I go back? Where is my keyboard? No, you're kidding me. Because if I click here, you get the keyboard. Oh. But when I click here, where is my keyboard? So I probably need the. I hope we can change this. Oh, here it is. Sorry, I was confused. Back. 10 megahertz. Enter. It does do that. Okay, and Bluetooth full power. Go back. I think I feel better if I just switch it on and off, because maybe the PLL needs to restart or something. Just do, I don't know, it just feels better. Is it still set? Yes, good. And then we do 50 and we do a point. Okay, that does work. And if you think, where is this? This is really like a 0.00, because if I go quicker and I take out the least significant, then this is more easy to read. So we were really like 2 numbers there. So that works. So we are running now on the 10 megahertz reference clock. Cool. Yeah, what we saw, if you do a point, then it is very clean, as you can see, and put intensity quite high, because you see better. But if I put a sweep, I put it now between 47 and 53, then you see it's creating a lot of noise. And the question was, if we put a sign instead of a square, maybe that disappears. Well, that could be, but it's actually doing. If you can see here, it is almost modulating the frequency. You can just see it, the others. And we didn't see that before because I didn't use this setting. Look at this. Signal everywhere. But let's put in a sine wave and see if that That is different. I will switch it off first, put the sine wave in it, and then switch it back on. So you see I'm not cheating. This is really very clean 10 megahertz from my SDIS5 distributor, and it is 10.0000000. So that is what I'm going to feed in now. Okay, same test. The point looks very nice. Switching off the point, doing the sweep. Yeah. Not too much different. Still very noisy. You can see it's cutting really. Well, good test. So that worked very well. We have a good signal. It is super well synchronized. It's all running on the GPSDO. I think this was a success. That was very cool. I decided in the end to put the software in the end anyway, because it all survived, and most people probably want to use the external reference, and only some are fighting with the software. So I downloaded a zip file, the PLZ-PLL435X, and that one I put in a subfolder ADF. So when I extract it, I at least know where to find the files, because the download folder will probably be very full, most people. So I extract just to its default folder. There we have it. There we have another folder. So I will move it down immediately, because let's move this down because we have a lot. Good. And back. And back. That we don't need. Oh, this was the original installer. Okay, here we have the PLL ADF-X. What is in there? Well, here are just a few pictures. Well, that is all good. I'm not using that, so we don't need remove that. Then we have here the ADF, and right here we have a debug folder, and I don't necessarily know what that means, but in here we find all the files that we need. So we're just going to extract this one. The whole structure is in there. So we're just gonna move this also. Okay, then we have all these folders. This we don't need. Okay, then we have a setup file. This was the main executable, the main zip. So we only have this debug, the file. We also just zip. We also don't need. So now we have a setup, and the setup. If you start, you will see immediately. Okay, this is for the serial driver, the CH340. But if you already have multiple USB devices, you maybe don't even need that. So I'm going to manage. I'm going to my hardware, and I'm just gonna look in my device manager in ports. Do I already have one? Yes, I have one, and it's COM3. So I will zoom in a bit. The computer already knows the driver, so I don't need to reinstall the driver. So the setup file we don't need, because maybe it is even older version, and then my other device also doesn't work anymore. So I'm now plugging in the generator. Bloop. And now we also see that we have an extra serial and it's COM4. So we know now, okay, it is 4. That's good, and we don't need to run the setup. So the setup we also don't need. And if you do not have that device, then of course you need to run the setup first, but I don't. So then we have only one left. So it's already a lot more easy. And now we have here the executable. So if we run the executable, it says COM3. Well, we know it's 4, so we move it to 4. Then the flash, I don't know. I don't use. I don't want to flash anything in my COM port, so I just say, okay, we do open COM, and there is no error, so probably that worked. So now we're gonna try put the 100 megahertz out of the generator. Just a point, and then it says, oh, you need to enter a value between 10 megahertz up to 100. And then I thought, yeah, but continue. But why? Because I just want 25 megahertz. Then I found out what was the trick. Take out the zeros. Just put 25, 100 here, point, and then it says, yeah, it is running. Data is sent, it works, and then you stop. Okay, and the same is for the sweep. You just have here your start frequency, your stop frequency, and you put sweep, and then it will start to sweep with the steps that you want. When you are done playing with this, but I prefer just using the display. Now this version has the display, so I don't need this program, but then at least you know how this works. Close the COM, and that's it. Actually was quite easy. So that's it. I tried to make it as clear as possible by moving the files too much, but maybe I complicated too much for you. But at least you know now how to do this. You can put the pause button if it was too fast. So thank you for watching, and I hope to see you next time.